This is a video on probability with a focus on the multiplication rule and Bernoulli trials. The multiplication rule states that the probability of A and B is equal to the probability of A multiplied by the probability of B. So when you see the word and, you want to multiply. We tend to use this rule when we have a chain of events and we can know the probability of each individual event and we want to find the probability of the overall chain of events. The probability that Matt wins at table tennis is 0.7. If he plays 3 matches, find the probability that he only wins the last one. So when making out the solution to this question, we need to think about those 3 separate matches. And I'm going to use these 3 bubbles to represent those matches. I want to find the chances that he only wins the last match. So he's going to lose the first one, he's going to lose the second one, and he's going to win the third. I know the probability that he wins is 0.7. What do you think is the probability then that he loses? Well, on any individual match, the chances of losing are 0.3. I want each of these 3 individual events to happen. I want him to lose the first, lose the second, and win the third. Since I want L and W, I must multiply these to get the answer. And when I multiply these values together, I get 0.063. And this is the probability that out of 3 matches, he only wins the last one. Example 2 continues on from example 1. It asks, what is the probability that Matt wins only 1 out of his 3 matches? But this time it doesn't specify which match I want him to win. So we could have the same lose-lose-win scenario as before. The values for losing and winning stay the same, and that outcome still has a chance of 0.063. But it's also possible that instead of winning the last one, maybe he wins the first one. Remember, I only want him to win once. So if he wins the first game, he must lose the second and third games. The chances of winning is 0.7 and the chances of losing is 0.3. Again, if I want him to win and then lose, I must multiply these values together. And in this case, I also get 0.063. Have I exhausted all my options? Is there any other way in which he might win one of the matches? Well, it's possible that he might win the middle match. And if he wins the middle match, well then he loses the first and the third. The chances for winning and losing are unchanged, so I can fill in my 0.3s and my 0.7. And again, if I want to find the chances of him losing the first, and winning the second, and losing the third, then I should multiply these together. And yet again, I get 0.063. Now, if I want him to win one of the 3 matches, I want for this scenario to occur, where he wins the last, or the second scenario, where he wins the first, or the last scenario where he wins the middle match. If I want to find the chances of one event or another event happening, I should add. So I will total together my outcomes at the end of each calculation. And so the probability that he wins 1 out of the 3 matches is 0.189. Okay, here's a third example. Jen plays soccer and camogie. One Saturday she has a match in both, and the chances of the soccer team winning is 0.4 and the chances that they'll draw is 0.3. The camogie team have a 0.6 chance of a win and a 0.2 chance of a draw. I want to find the chances both win, both lose, and soccer wins and camogie draws. The first thing that I should do is make a note of all the probabilities for all the possible events. So let's start with soccer. The probability of a win in this case is 0.4. The probability of a draw is 0.3. What do you think should be the probability that they will lose? Well, these are all the possible situations for the soccer team: win, lose, or draw. And so they should add up to 1. So 0.4 and 0.3 makes 0.7. I need 0.3 to make up a total of 1. Let's do the same now for camogie. For camogie, the chances of a win is 0.6. The chances of a draw is 0.2. Calculate yourself now what the probability is that the camogie team will lose. It's 0.2. Now we have all the information that we need to answer the questions. First of all, let's just look at the way part 1 is phrased. It asks us the probability that both teams win. Could I phrase this using the word and? When I see that both win, that means that I'm looking at the probability of soccer winning and camogie winning. So this lets me know that I should be using the multiplication rule. So I've got my 2 events. I've got my soccer win. I've got my camogie win. I want both of these to happen. So I'm multiplying the values together. And the probability of a win in soccer is 0.4, and the probability of a win in camogie is 0.6. And when I multiply these, I get a result of 0.24. And this is the probability that both teams win. Next, we need to find the chances that both lose. Again, I can phrase this as soccer lose and camogie lose, and tells me that I should multiply. I'll title these two events as SL for soccer lose and CL for camogie lose, and I'll have to multiply whatever those values are. Looking back to my list from previously, the chances of a soccer loss is 0.3, the chances of a camogie loss is 0.2, and when I multiply here I get a result of 0.06, which is the probability that both teams lose. Finally, we want to find the probability that soccer win and camogie draw. So I'll call them SW for soccer win and CD for camogie draw. The and means I know I must multiply. A win in soccer has a chance of 0.4. A draw in camogie has a chance of 0.2. And so the result for part 3 is 0.08.